So we're now looking at the second question on the workshop, which is you've got 4 bonds and you've got to determine which of these bonds has the longest duration. So we've got bond A, which has a maturity of 9 years and a duration equal to, well, we don't know, and it's got an 8% coupon. Then we've got bond B, which has a maturity of 9 years. Again, we're trying to find the duration, and it's got a coupon period of 12%. And then we've got bond C, with a maturity of 16 years, duration equal to, well, that's what we're trying to find out, but a coupon of 8%. Bond D, maturity 16 years, we don't know the duration, and the coupon is 12%. So let's compare a number of bonds. And if you remember, the relationship between duration and coupon is a -1. Duration and yield to maturity is a -1. And duration in time is a +1. So if we considered 2 bonds with the same maturity, for example, bond C and bond D, you'll see that because bond D has the larger coupon, that means it's going to have the shorter duration because more of the cash is paid up front. So this one, of course, if we assumed a par value of $1,000, is going to pay $120 each year for 15 years, and then the par value plus the 120 in the 16th year. Whilst this one here, you'll see, only pays 80, assuming a par value of 1,000 each year for 15 years, and then 1,080 in year 16. So the duration of bond C relative to bond D is that because bond D has more of its cash flows sooner rather than later, that the duration of bond C is greater than the duration of bond D. Likewise, if we compared bond A against bond B, they both have the same maturity, 9 years, but by the same logic you can see that this one here pays more cash up front, so it's going to have the shorter duration. This one here pays less cash up front, so it's going to have the longer duration. So we can argue then that the duration of A is greater than the duration of B. Now we've got to determine, we've got the order between C and D and A and B. Now we come back to this relationship here, that the maturity is positively related to duration. And I remind you of a chart in the lecture, which looked like this. So here we've got duration and here we've got maturity. That if we had a 0 coupon bond, D would equal T. So if that was 9 and that was 16, the durations would be 9 and 16. If we then consider a bond that paid a coupon of 8%, then you can see that, well, for a call from the lecture slides, that it would look something like this. So coupon equals 8%, and then coupon equals 12%. It's very difficult to determine this without actually doing the calculations, but the force from maturity on duration is much greater than the pressure from the coupon payment. So from this we could argue that in order of duration it would be C, followed by D, followed by A, followed by B. And if you actually undertook these calculations, you would find the following. So if you assumed a par value of $1,000 and a yield to maturity of 10% and priced these bonds and found their duration, you would find that the duration of this one is 8.99 years. The duration of this one here is 8.33 years, so C is longer than D. And then you would find that the duration of A is 6.59 years and the duration of B is 6.13 years. So if you assume par value of 1,000, a yield to maturity of 10% and these other characteristics, this is what you will get. But as you can see, recalling from this diagram, the force or the impact of time on duration is much greater than the impact of a change in coupon. So as you can see, it's much, looking at the shape of the diagram, you can see that it's logical then that the duration of the 16-year bond with the same coupon would be greater than the duration of a 9-year bond with the same coupon. As so. Okay, hopefully follow that.